Hello, this is a walkthrough of the Edexcel Maths GCSE Higher Paper 1 Non-Calculator from May 2023. There are two options I would suggest for doing this paper. You could either do the whole thing and then watch my recording to see which parts you got right, which parts you got wrong and how to do it. Or you might want to do it question by question. So you complete question 1, pause it and see how I do the answer. So obviously this is what our calculator, 8.46 divided by 0.15. I'm going to write it as a fraction first. That's what I do when I'm dividing by a decimal. Then I'm thinking, well, don't want to be dividing by a decimal. Let's make this easier. Multiply that by 100, multiply this by 100. 846 over 15, which I'm going to do is I'll stop. Write out my 15 times table. 15s into 8 is 0, remains 8. 15s into 85. 1, 2, 3, 4, 5. So we've got 75. So the remainder is 85. No, that should be a 4. So the remainder to 84 is 9. 15s into 96. 1, 2, 3, 4, 5, 6. Got a remainder, so we need to add a decimal point here. Got to 90, want to get to 96, the remainder 6. 15s into 60, 4. So your answer should be 56.4. Okay, work out 7 3/8 minus 2.5. I'm going to write them both as improper fractions first. 7 times 8 is 56, add 3 is 59. So you've got 59/8 minus 2.5. 2 times 2 is 4. 4 plus 1 is 5. Then I'm going to make them into equivalent fractions using a common denominator. The lowest common multiple of 2 and 8 is 8. This fraction is already out of 8. What do you multiply 2 by to get 8? 4. So you multiply this by 4. Leave the denominator the same, subtract the numerators. Change this to a mixed number fraction. 8 into 39. 8, 16, 24, 32 is 4. And we've got 7 left over. So 4 and 7/8. Cube has a total surface area of 150 centimeters squared. So that means if you add up the area of all the faces, you get 150. A cube has 6 faces, so I'm going to do 150 divided by 6. You get 25. So the area of each face of a cube is 25 centimeters squared. Your cube's made of squares, right? How do you work out the area of the square? Base times height, but they are the same, the base and the height, so it's got to be 5. The dimensions of your cube are 5. How do you get your volume? Base times height times depth in any order, but 5 times 5 times 5. 5 times 5 is 25, times 5 is 125 centimeters cubed. Frequency polygon, so we need to plot the midpoint against the frequency. Midpoint is 2.5. Here it's obvious what the midpoint is, but if you weren't sure, you'd add these numbers together and halve them. My scale on my graph looks pretty straightforward as well. So let's just say 22.5. Let me write it clearer. 2.5 is in the middle of 0 and 5 to 8. 7.5 to 24. 12.5 to 13. 17.5 to 11. And 22.5 to 4. Drawing them up with a straight line. Sorry, I don't have a ruler function here, but just make sure you've drawn yours up with a straight line. A bit of set notation. Universal set is all of these numbers 1 to 10. Odd numbers. So what are the odd numbers here? 1, 3, 1, 3, 5, 7, and 9. Square numbers, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, but it's not included in the universal set. So what numbers occur in both of these lists? It's 1 and 9, so they go in the overlap. B, what's left over in our square numbers? 4. What's left over for A? 3, 5, 7. All the other numbers go around the outside to 2, 6, 8, 10. Find the probability that this number is in the set B dash. B dash means not B. So these are all your numbers in B. What's not in B? So 1, 2, 3, 4, 5, 6, 7. 7 out of, how many numbers have you got altogether? 10. Scatter graphs. Describe the relationship. So it doesn't want positive correlation here. It wants something along the lines of what happens to the weight as the age increases. So as the age of the babies increase, the weight also increases. Something along those lines for your 1 mark. Let me just see what else they allow here. Yeah, as age increases, weight increases, the older, oh, it does accept positive correlation, excuse me, sorry. The older you are, the greater the weight. Does not accept just saying positive. Right, so you could say positive correlation there. Okay, another baby has a weight of 5.8 kilograms. Use the scatter graph to find an estimate for the age of the baby. I'm just going to snip this over so I can actually use a ruler for this. Sorry, just bear with me a moment. It wants you to use your graph here. So your line of best fits, you want a line that kind of follows the general trend of your graph and has an equal amount of points on each side. Don't join the first dot to the second dot. It does not want to see that. Also doesn't want to see it from the origin. So I'm just gonna go, let's see how many cross I've got each. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay, can we do the bit further up perhaps? So, yeah. 1, 2, 3, 4, 5, 6, 7. No, I'm gonna put it more like that actually. Yeah, there we go. Right, so it wants the age of the baby, 5.8 kilograms. So there's 5. Going up in 0.2s this, right? So 5.2468. I would get the answer of 3.246. 3.6 is the age of my baby. So the examiner would check, make sure you put these lines on your graph, just, oh, where has it gone? Just to show you've used your line of best fit. It will check, the examiner will check if you have actually used those. It wants the answer in a range of 2.5 to 4.5. Price of holiday increases by 20%. The 20% increase adds £240. So it means this 28% represents £240. So we're working out what's 100% here. Like what's the cost of the holiday? So if 20% represents £240, 20% is half of 10%, right? So let's halve it. 120. And then 100%. Times that by 10. To get 1,200. Next question. Pressure equals force over area. We don't have our area. We've got the force here, don't we? So we've got force. We want the pressure. So pressure equals 90 over the area. Well, what information we've got to find the area of the cylinder? To find the volume of a cylinder, it's area of base times height, pi r squared h. So we know the area of the base, which I'm not sure of. I'm going to call it A, times 40 is 1,200. Let's make A the subject by dividing both sides by 40. Cancel the zeros. 120 divided by 4, 30. What's 90 divided by 30? 3. Use the graph to solve these simultaneous equations. So what's the value of x and what's the value of y? It's where they cross, isn't it? Because they're the same here. X is 6, y is minus 2. So you just read off your x value and your y value from your graph. Pentagon. AED equals 4 times angle ABC. I'm going to call ABC x, and if this is 4 times this, so it's 4x, right? Now, what's angles in a pentagon? You might just know it's 540. You might want to use the Angleson formula. N minus 2 times 180. So the number of sides is 5. So what's 5 minus 2 times 180? 5 minus 2 is 3. 3 times 180 is 540. I'm going to just make an equation here, right? So if we add all these together, at 540. 120, add 135, add 110. You might want to do this mentally in your head. 4x add x is 5x. So now we've got our equation. I'm going to subtract 365 from both sides. Again, you might want to do this in your head. I'm going to do it as a subtraction. Can't do that. Need to borrow 1 from here. 10 take away 5 is 5. You can't do 3 take away 6. Borrow 1 here. 13 take away 6 is 7. 4 take away 3 is 1. So 5x is 175. I want 1x. I'm going to divide both sides by 5. What's 5 and 175? So x is 35, but we want angle AED. So what's 4 times 35? 140. Okay, so we want to write this in the form A, x to the power B, y, c. So let's just simplify this. So we're squaring everything in the brackets here. Just as a reminder, what are the rules of indices? When you've got like a power to a power, you multiply them. So we're squaring everything in here. What's 6 squared? 36. X to the power 5 squared is x to the power 10 because you multiply your powers. Y cubed squared is y to the power 6. 3 times 4 is 12. X squared times x, right, is x cubed. Y to the power 7 times y to the minus 3. So here we're going to add our indices. 7 add minus 3 is the same as, well, when you add a negative, it's the same as subtracting, right? 7 take away 3 is 4, so y to the power 4. Let's simplify it again. 36 divided by 12 is 3. X to the power 10 divided by x cubed, you subtract your indices here. 10 take away 3 is 7. Subtract your indices here. 3, x to the power 7, y squared. Okay, probability tree diagram. Shows the probability Martha will win or lose. Find the probability that Martha will lose at least 1 game. So here, along this first branch, she's winning and winning. Well, that's not losing at least 1, is it? We don't want that option. Next one, we've got a win and a lose. Well, that's at least 1 lose. So we want that option. I'm going to just put win, lose for now. Here, lose, win. Well, she's lost at least once there. Lose, lose. She's lost at least once here. So what do? You multiply your fractions along your branch. So the probability of a win times a lose is 5/8 times 7/9. Multiply your fractions. Okay, I'm going to do lose win next. Don't know why I put that in brackets. And lose lose. Right, it's that option or that option or that option. So we add them together. Add your numerators, leave your denominators the same. 30, 40, 56, 62 over 72. It doesn't ask you to simplify it, but if you have, you may have got 31 over 36. Okay, next one. Y is proportional to X. So for a relationship that's directly proportional, so one variable increases, the other increases by the same amount, which is why you get your Y equals KX. K is your constant of proportionality, stays the same. We know 24 equals K times 1.5. How do we work out K? Divide both sides by 1.5. How do I work out that division? I'm going to multiply the numerator and denominator by 10. 15's into 240. 15's 24 is 1, remainder 9. 15's into 90 is 6. K is 6. So from here, this equation, we know that Y is always equal to 16 times X. 16X. Don't really need the times there. So work out the value of Y when X is 5. I'm just going to sub X is 5 into this equation. Y equals 16 times 5, which is 80. Now, if it's in this, if it's a fraction with 1 at the top, that means it's negative power, doesn't it? So 1 over 16, well, I know 16 is 4 squared, so it's 4 to the minus 2. These are quite difficult to remember, these. I find a lot of people might start struggling from here. Well, but you might just know I need to start practicing these topics, negative indices, fractional indices. 8 to the power 5 over 3. That 3 means the cube root of 8 to the power 5. This means 2 means the square root of 9, power 3. Cube root of 8 is 2, 2 to the power 5 minus square root of 9 is 3, 3 cubed, 2 to the power 5. 2 times 2 times 2 times 2 times 2. 2, 4, 8, 16, 32. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. 32 take away 27 is 5. So you've got the equation of two lines here. L1 and L2 are perpendicular. Now, if your lines are parallel, the gradient's the same. If your lines are perpendicular, the gradient of one is the negative reciprocal of the other gradient. Well, I know the gradient for L1 because it's in the form y equals mx plus c. So your gradient here is 2. What's the negative reciprocal of 2? Well, the negative reciprocal means minus 1 divided by 2. Minus 1 divided by 2 is minus 1/2. That is your gradient of the perpendicular line L2. Right, this is not written in the form y equals mx plus c. I need to do that first of all. What I'm going to do is I'm going to add 12 to both sides. Then I'm going to minus kx from both sides. Then I'm going to divide both sides by 6. I'm going to rearrange this a bit as well. Right, 12 divided by 6 is 2. But I want my mx plus c, so hang on. So y equals minus k over x, minus k over 6x. 12 over 6 is 2, and it's a positive 2. So now I know m is minus k over 6, but I also know it's equal to minus 1/2. Times both sides by 6. What's minus 1/2 times 6? Well, what's minus 1/2 of 6? Minus 3. Minus k equals minus 3. Divide both sides by minus 1. K is 3. You might be able to tell that from that step anyway. 3/8 of the surface area of this sphere is 75 pi. Well, I've already got my 4 pi r squared formula for my surface area of the sphere. So 3/8 of 4 pi r squared equals 75 pi. I'm going to replace my of with a times. And I'm actually going to replace it. Right, so how am I going to do this? So I think there's a couple of different ways you could do it. I'm going to change this 4 into a fraction over 1. And then I'm going to multiply them. 3 times 4 is 12. 8 times 1 is 8. So you've got 8 pi r squared equals 75 pi. It's quite difficult to do this without a calculator. But I'm going to simplify that fraction first. 12 over 8 is the same as 6 over 4, which is the same as 3 over 2. 3 over 2 pi r squared equals 75 pi. Times both sides by 2, which gives you 3 pi r squared is 150 pi. Divide both sides by 3, gives you pi r squared equals 50 pi. Divide both sides by pi, gives you r squared equals 50. Square root both sides, but we need to write it in the form a root b. What square numbers divide into 50? Well, 25 divides into 50, so we can write it like this. 25 times 2 is 50. Let me separate it. Root 25 times root 2. Root 25 is 5. 5, so it'll be 5 root 2. That's the radius, but we want the diameter. The diameter is double the radius, so if you double 5 root 2, 10 root 2. Make x a subject. So I can tell by looking at this that we're going to be, a lot of you are going to be in a situation where you can start it and then you're not sure how to continue. When you get to that sticking point, you need to remember to factorize. Right, let me just explain it. So you expand the brackets at the top. I'm going to multiply both sides by 5x plus 3. Put it in a bracket. Expand your brackets. Right, I imagine a lot of you would have got to this stage. Next thing, you want to get anything with an x on one side, anything without an x on the other side. I'm going to gather my x's on the left, on the right hand side. Doesn't really matter because there are 2 different answers for this. So I'm going to add 28 to both sides first. Then I'm going to subtract 5xy from each side, and then you'll see I've got anything with an x on one side, anything with an x on the other side. So this is the point here when you factorize it. To isolate the x's by putting it in a single bracket. If I take an x out of both of those, then I would have 8 minus 5y inside my bracket. If I expanded the bracket there, I get 8x minus 5xy. And then my last step, which I'm going to do over here, is dividing both sides by 8 minus 5y. And then you'll see I've got x is the subject, x is equal to this. Or alternatively, you may have the answer minus 3y minus 28 over 5y minus 8. Okay, we've got 7 kilograms of carrots. So we know the cost of 7 kilograms of carrots, 5 kilograms of tomato is 480 pence. Ooh, the cost of 1 kilogram to the cost of 1 kilogram tomato. Right, okay. So I'm thinking, let me just look at the fraction. I'm going to write this as a fraction. The cost of 1 kilogram of carrots to the cost of 1 kilogram of tomatoes is a fraction. So 5/14. So if we we know that the proportion, the cost of the, it's quite a tricky question this, the cost of 1 kilogram of carrots, the cost of 1 kilogram of tomatoes is in the proportion 5/14 to 9/14. Because in total, if you've got 5 kilograms of carrots and 9 of tomatoes, you've got 5 out of the total of 14. You've got 5/14 carrots. Hopefully that makes sense. 5/14 tomatoes. Now, got it as a proportion here. I've got it as an equation here. So we've got 7 kilograms of carrots. 7 times 5/14 is, again, make it into a fraction over 1. 35/14. And do the same with my tomatoes. 9/14 times 5. 45/14. Now I've got my ratio, including your 7 kilograms of carrots and 5 kilograms of tomatoes. So your ratio 35/14. So you can make it into a ratio of 35/45, if that makes sense. Carrots to tomatoes. Let me simplify this by dividing both by 5. 7/9, which is a total parts of 16. I'm going to divide my 480 divided by 16. So hang on. 16s into 480. You've got 16, 32, 48, 3, 0. It's 30. Because we've been dealing with this cost here, so that means that the cost of a carrot is 30p. And we can do something divided by 30. And now we've got the cost of a carrot. Hang on. Let me just think about this. 1 second. Sorry, I was a bit lost with what I was doing there. So 480 divided by 16 is 30. That's 1 part, isn't it? So 1 part we've worked out is worth 30. So we've got 7 parts here in our ratio. So 7 times 30 is 210. And 9 times 30 is 270. So can you see that's the total cost of my carrots here? And that's the total cost of my tomatoes. Because I know 270 plus 270, sorry, 210 plus 270 is 480, and in that proportion. So 210, we want the cost of 1 kilogram of carrots and 1 kilogram of tomatoes. 210 divided by 7 is 30p. And 270 divided by 5. Let's just do a quick bus stop method for this. 54. Okay, the menu in a restaurant has starters, mains, courses, and desserts. Hopefully you know from your combinations work. 5 times 12 times x give you all the different ways. So we know 5 times 12 times x is 420. 5 times 12 is 60. 60 times x is 420. Divide both sides by 60. 420 divided by 60. So 7 would be your x. 7 desserts. Functions. So we want the inverse function for g. So to find the inverse function, you just follow some steps. You need to put this equal to y. Now I need to make x a subject. I'm going to times both sides by 5 first. Then I'm going to take 2 off both sides. I'm going to square both sides. Then we need to write it in function notation where I'm going to replace. I'm going to write this down here. That's my inverse function. Replace the y for an x. That's your answer for that one. G of f of x equals 3. F of x is this. So I need to then substitute that into my g function. So into my g function, wherever there's an x, I'm going to replace it by 3x plus 4. And we know that answer would be equal to 3. Now I need to make x a subject. So let's times both sides by 5. Subtract 2 from both sides. Square both sides. 13 squared is 169. Take 4 from both sides. Divide both sides by 3. X is 55. So we want to work out the angle ADC. ADC. This one here. I'm going to write down any circle theorems. A lot of people think this is the bow theorem, you know, the one where you've got angles in the same segment are equal, but it's not, because all your corners don't touch the circumference of your circle. This is the, like, I call it the arrow theorem, you know, like this one. Angles at the center are double the angle at the circumference. This is that theorem in disguise. So can you see you've got an angle? Might snip this over 1 second. So you can see here, that's your angle at the centre, and that's your angle at the circumference. So your angle at the centre is double your angle at the circumference. So BAO is at half of that, which is 32. So I'm going to say DAB. What did I call it before? I'm not sure what I called it before, but DAB. Because you've gone from D to A to B equals 32. And your reason is angle at the centre, double angle at the circumference. I've seen a tangent there. Have we got a tangent touching a radius? Well, yes, we have, because that's the centre. Tangent touching a radius is 90 degrees, so ODC is 90. Angle, yeah, sorry. Tangent touching a radius. So because that's 90 degrees. Right, I can go, we need some more information here. Right, let's pop this on. What was this one? 32. Right, I'm going to get this angle here. 32 add 51. 83, 180. Take away 83 equals 97. So this angle here is 97. Opposite angles are the same. This angle here is 97. Then we got 97 plus 64. Which is that angle there is 19. And then we decided this was a right angle, didn't we? So 90 take away 19 gives you 61. No, it doesn't. Gives you 71. Okay, so just make sure you learn your circle theorems for that, please. Work out the angle. Ooh. 3D trigonometry with our calculator. AF is 66.8. F to C. Work out the size of the angle between FC and the plane ABCD. So it's like where that line touches your rectangle. Asking for this angle here. You see that that's a right angle triangle in there. And we know F to C is 13.6. Hopefully you can see it Sokotoa. Let me draw out my right angle triangle here. 6.8, 13.6. Here's my unknown angle x. Sine x equals O over h. Not sure where this is going. I'm hoping this is going to simplify into something nice. 6.8. Oh, this simplifies to a half, doesn't it? Half of 13.6 is 6.8. I don't know whether you would have noticed that. You may have thought times them both by 10 to get 68 and 136, and then simplified it to get your half. So this is just knowing your sine ratios. This is the one I always remember. Sine 30 equals a half. So x is 30 degrees. And towards the end of the paper now. Okay, yeah, last two questions. So rationalize the denominator. So I'm going to do it with my 2 over root 3 first. Multiply both sides by the numerator and denominator by root 3. 2 root 3 at the top. Root 3 times root 3 is 3. Right. To rationalize the denominator here, you need to multiply it by the same thing, but with a different sign. So it's 4 plus root 3. So if I multiply the denominators here, 4 minus root 3 times 4 plus root 3. 4 times 4 is 16. 4 times root 3 is plus 4 root 3. Negative root 3 times 4 is negative 4 root 3. Negative root 3 times root 3 is just negative 3. Multiply the numerator by expanding the brackets. 3 root 3 times 4 is 12 root 3. 3 root 3 times root 3. Well, root 3 times root 3 is 3, times 3 is 9. Now, if you just simplify the bottom of that fraction, you'll see that they disappear. 16 take away 3 is 13. So now we have 12 root 3 plus 9 over 13 minus 2 root 3 over 3. So what's our common to subtracting fractions? What's your common denominator? I'm going to get that by doing 13 times 3, which is 39. I'm going to multiply all of this by 3, which gives you 36 root 3 plus 27. I'm going to multiply all of this by 13, which gives you 26 root 3. Now let's simplify it. 36 to root 3 take away 26 root 3 is 10 root 3 plus 27 all over 39. Okay, so we're going to find the set of possible values of x. We've got quadratic inequalities here, haven't we? So I'm going to make them, well, I'm going to start with this one. I'm going to make it equal to 0. I can see this is a double bracket difference of 2 squares because you can square root 4x squared, you can square root 25. If I solve that, this times this is 0, so x, well, let's just write this out properly. So either 2x minus 5 equals 0, in which case add 5 to both sides. Divide both sides by 2. X is 2.5. If you do the same here, we're going to get x is minus 2.5. Now I'm going to sketch a graph. So crosses your x-axis at 2.5, minus 2.5. Positive quadratic. Wants to know here when your graph is below 0, doesn't it? You see here, when is it less than 0? It's below your x-axis. So there's all these answers. What x values produce these answers? It's all of these. So x is between minus 2.5 and 2.5. Right, I'm going to do the same here. Right, first of all, I'm going to make x the subject. Sorry, no, I'm not. It's quadratic. But I want a positive x squared term. So I'm going to bring everything over to the right-hand side here. So I'm going to add 3x squared to both sides. I'm going to add 5x to both sides. I'm going to take 12 to both sides. So you've got 3x squared plus 5x minus 12 is less than 0. So next step, let's put equal to 0 and factorise. Now, there are a few different ways of factorising double brackets when the coefficient of x squared is greater than 1. I'm going to use the splitting down the middle method. 3 times negative 12 is negative 36. You've got the middle term 5. So what two numbers multiply to get negative 36 and add to get 5? I think it's something to do with 9 and 4, because 9 times 4 is 36. It's negative, so one of these is negative. So it's got to be positive 9, negative 4, right? So you've got 3x squared. Add 9x, take away 4x, minus 12. Factorise, split it down the middle, each into a single bracket. I expanded this, get the same thing. One of my brackets is 3x minus 4. The other is x plus 3. So this first bracket was equal to 0. Add 4 to both sides. Divide both sides by 3. Or this other bracket's equal to 0. X is minus 3. And we're going to sketch my graph. Do it down here. So it crosses your x-axis at negative 3. Or 4 over 3, which is 1 1/3. I'm going to go back to this bit here, where you've got positive x squared terms, and my graph's like this. We want to know when it's less than 0. So again, where is it below your x-axis? Yeah. So for all these values here. So x is, in this instance, between minus 3 and 1 1/3. We want, though, x has got to be satisfy both inequalities. So I'm going to have to take the smallest one here, the minus 2.5. X is bigger than minus 3, but bigger than minus, but it's got to satisfy both. So I'm going to have that smaller one. And then it's got to be smaller than 2.5, smaller than 1 1/3. So I'm going to have to take my 1 1/3 there. Or you could just keep it as 4 over 3, but that's your final answer. Okay, finished. Hopefully you found that useful. You should find paper 2 and paper 3 in the YouTube. So you can have a look at those maybe next. Okay, thank you.